Hello there, my name is Mayank Soni. So today we are going to learn combinational circuits using Verilog VHDL. So what is Verilog HDL or VHDL we can say? Verilog is used for digital hardware design or it is used for describing behavior of hardware. This language was developed in 1984 and further modifications were done in this language and it came into IEEE standard and it got IEEE standard of 1364 1995 and more modulations came in 2005 even, and after that in 2009 it came with IEEE standard 1800. So what is Verilog and VHDL differences we will discuss here. Verilog, it is used to model electronic system, and VHDL is used in electronic design automation to describe digital and mixed signal system. Verilog is weakly typed while VHDL is strongly typed. Verilog is based on C language, whereas VHDL is based on Pascal and Ada language. Verilog is case sensitive and VHDL is not case sensitive. And simple data types are used in Verilog, while in VHDL more complex data types are used. Verilog is newer than VHDL. Of course, it is newer than VHDL. First, the VHDL was developed. After that, Verilog was developed. Verilog is basically used for verification of the codes, or we can say the circuits which we have made. More further verification, we use Verilog. And for development also, it can be used. So VHDL, it is older version of Verilog. Verilog is lesser complex than VHDL and VHDL is more complex obviously. So what is the framework of Verilog? We will discuss about the framework. So it is as simple as VHDL. If we have learned about VHDL, we have to write module, then the module name and the module on which it is dependent, the variable on which the module is dependent, the inputs, outputs, and the statements which have to be executed, and after that the keyword end module. So we will study some of the properties of Verilog in brief, not much in depth, so that our basic concepts are clear about Verilog. So here a tip for more knowledge from where I took this knowledge. I have provided a YouTube link on which you can go and gain some knowledge. Abstraction. Abstraction, this is one of the first property of Verilog. It is independent of technology. As we know, many more and the chips are getting more and more smaller in size. Once a time there were about of 180 nanometer and then it kept on decreasing and nowadays it is about 7 nanometer. So we can implement Verilog on any size of chip. It is independent of the size. Next, concurrency parallel operation. The statements, or we can say the circuits which is being implemented in Verilog, they execute parallelly. So it makes the language and hardware, or the softwarely implemented hardware, speed up its performance. So concurrency is second property of the Verilog. Vendor neutrality. What do you mean by vendor neutrality? Look, we have a lot of companies which make synthesis tool in market. So it is not like that they have their own Verilog RTL schematics and syntaxes, semantics. No, Verilog is same for every vendor in the market. So there is no monopoly. The code run independently without any change in semantics. Scalability is another property of Verilog. It means we can change the code as per our requirement whenever it is being required. It is also like reusability of the code. Just like in VHDL, we can make any module, for example, in half adder, in full adder. In full adder, if we have created half adder as an entity, so we can use that module again in the full adder. So it's also applicable in Verilog. So modeling styles in Verilog. We have four modeling styles in Verilog. Gate level modeling, in which designing is done using basic gates primitive initiatives. Data flow modeling, designing is done by using logic equations or Boolean expression. It is as like as VHDL. Behavioral modeling, Designing is done using high-level constructs like loops, delays, case functions, if else. There is nothing changed in Verilog and VHDL. They both are very much similar. Structural modeling. In structural modeling, we use instances, smaller parts, which are used in data flow modeling or behavioral modeling. So we are not going into much deeper. We are not going into much deeper in behavioral or structural modeling, and we will implement the circuit by using data flow modeling only. I will show you some syntax of gate level modeling. It is very simple. As you can see, the syntax is like this. You have to write the gate which has to be implemented or which has to be executed, and the primitive name, whatever name you want to give to the name to the gate, and the output input on which the circuit depends. Example, the NAND N1 is name given to the NAND, out in 1 into. These are instances of an NAND gate hardware. Just like this, XOR and NOT, XNOR. It is the most simplest form, gate level modeling. Next, data flow modeling. It is as simple as gate level modeling. We have to do nothing. Just we have to write assign C equals to A and B. This is for AND. As you can see, the A and B are ANDed together, and this value is being assigned to the C. So assign the net expression equals to assigning operator expression of different signals or constant values, which is to be assigned to the net expression. So the circuit which we are going to implement is 3-bit parity generator. 3-bit parity generator. It's truth table. The K map I've already provided so that it would be a bit easier. And this is the logic equation A XOR B XOR C for the output parity output even bit parity generator P. And this is the logic diagram of 3-bit parity generator. So it's quite simple. Let's implement the design. Now I'm going to Xilinx ISE 8.1. I will go to file, the new project. I will name, as we are going to implement even parity generator, so I would like to name it like parity even. Now, instead of choosing VHDL module, I would like to choose Verilog module. The inputs we have are A, B, C, as it is 3-bit parity generator, and even parity generator. So I'm taking even as output and else the 3s as input. Next, next, and then finish. So you can see the module name ABC in even, input A, input B, input C, and output even. These all are sensitivity list. Now I will do nothing, just I will write the keyword assign even A XOR B XOR C. Keep in mind that Verilog is case sensitive. So if you use the capital V, it will respond in error. Now it's done. It's quite simple, just like VHDL. I will check the syntax. The syntax is check syntax completed successfully. The RTL schematics, I will show you the RTL schematics of even parity generator. all the three inputs are XORed to produce even parity. We'll cross this out. Now I will go to behavioral simulation. After that, I will create a test bench waveform, and I will give the file name as even p underscore tb. Since it's combinational circuit, I will click on combinational circuit, then finish. Look, it's as simple as VHDL. Nothing is different. I'm setting up the inputs for the required output. Let us see. Now, this is the test bench code, which is by default generated in the VHDL. So here I'll be with the output even. You can cross verify with the truth table that when A is equals to 1, B equals to 0, C equals to 0, so there is even parity. When A equals to 0, B equals to 0, and C equals to 0, so there is no even parity. Likewise, the sequence follows. Thank you. I hope you understood the basic concepts of Verilog. I've tried my best. And further, I have provided the link to. For more knowledge, you can go there. It is very easy to understand and just like VHDL. Thank you.